Great. Well, thanks for coming out today. I've just got off a plane from Australia about 2 hours ago, so I'm a little tired, but it's good to see you all here. And as I was introduced, I'm from the University of South Australia. We have one of the largest AR and VR research groups in the world in universities. In fact, we just discovered that we've published more papers than any other university in augmented reality in the last 20 years, so it's a great place for me to be. So there are many things I could talk about, but today we're going to talk about augmented teleportation, and in particular, collaboration. So this is a typical meeting space here. You can see when people meet, they exchange a lot of verbal and non-verbal communication and also talk about things in the environment. So here you have some architects meeting, talking about models of buildings on the table and being able to see each other. So you can see that we have the task space, which is this kind of a subset of the communication space. So people can look at the objects on the table while they're seeing each other as well. I should also mention that I'm happy to share all these slides with you as well. So at the end of the presentation is my email address. I'll give you all the slides and all the videos. So if you don't want to take photographs of all the slides with your cell phones, then I'll give it away to you at the end anyway. So when we introduce technology into the mix, something happens. And so you can see here some architects now sitting around a monitor. And now the task space is on the monitor, but the communication space is a little bit separate. You can't really look at the monitor at the same time as the person beside you. And the same thing happens with remote collaboration. So here's some people teleconferencing. They've got a very nice system with a couple of monitors, everybody around the table. And again, you've got the task space. They're talking about this molecular visualization and the communication space and this big kind of seam in the middle. And so one of the things that we're trying to do at the University of South Australia is how can we get rid of this communication seam and make remote communication and face-to-face communication more natural, like unmediated communication. And so augmented reality, it turns out, is really good for that. So here's a couple of people talking around a table wearing the HoloLens, and you can see again now the task space is a 3D model that's floating in space in front of them, and they can see that 3D model at the same time as they can see each other. So now we've again made the task space a subset of the communication space, and they can use very natural gaze and gesture cues to talk to each other and also interact with the model using very natural 3D gestures. Similarly, a number of other research groups around the world have looked at how you can use augmented reality to enhance remote conferencing. So you've got Microsoft's room-to-room where you project projections of people onto furniture in the real room. So it looks like the person sitting across you in the real room. Or the holoportation where you have a 3D model of somebody standing in front of you in the room. And Object Theory from Oregon have developed a system where you've got a mixture of people in the real room with you with HoloLens and also remote avatars as well. A very nice example of this is a project done from Vienna. And in this case, they're able to use a couple of Kinects to capture 3D volume of this person playing the guitar, and they're able to reconstruct it. So in this case, he's seeing himself, or you're seeing him through the HoloLens playing in the room with you, but you could just as easily take that 3D reconstruction and send it halfway across the world and have this person sitting in the real world in front of you playing the guitar. So that's very nice, except in this case you're looking at them as you're looking at in the real world face-to-face. What we want to do though is change the perspective, and we want to be able to view from the remote user's perspective. So take a remote person and put them inside your body so they can look through your eyes. And you can do that. This is a very old project from British Telecom over 25 years ago called CamNet. And this person's wearing a wearable computer with a camera on his head and had some video conferencing hardware. So he could live stream the video from his head to a remote person. And the remote person could also point and show some virtual images back to him. So the remote person had got the feeling that they were looking through their eyes. And a few years later, Carnegie Mellon found that by doing that, you could cut the performance time for certain physical tasks in half because the remote person could show you what to do. More recently, Google Glass did the same thing, so you can combine a camera with some processing, display, and connectivity, and you've got this opportunity to do ego vision collaboration. You can live stream a Skype or a Hangout from your perspective, and you can feel like you're really looking through somebody else's eyes. So a couple of weeks ago, Microsoft at the Build conference showed this video, and this is using the Microsoft HoloLens with this new remote assist software that allows you to stream video from the HoloLens to a remote person who can then help you perform tasks. So this lady's trying to operate this piece of equipment. It's not working out very well, and so she's going to call her remote expert colleague, and using the HoloLens, she makes a kind of a Skype call, and the colleague appears floating in space there, But for the colleague, they can see what she's seeing through the HoloLens. So here's her colleague on the desktop, and they can put virtual annotations into her view. So she's putting virtual arrows and drawing on her space. She's just loading up a help page from the manual there. Now she can draw on the screen and drop virtual arrows in space. So again, this allows the remote person to basically change their perspective, see through your eyes, and put things in your real world that helps you perform the task. And she's still stuck, so she's putting a second person in, so now she's got two people helping her, and she's able to draw and things like that. So that's really fantastic, but there are some limitations. So one limitation is that the remote person can only see through your eyes. So their view is fixed to your view. They don't really have much awareness of what's around them. So they have a lack of spatial understanding. There's only a few communication cues you can send. There's no gestures. It's not the same rich communication you have in face-to-face collaboration. And as I said, very limited situation awareness. So in our lab, we've developed a few systems that go beyond that, and I'll show you those now. One of the first ones was from a few years ago called social panoramas, and the idea was that you could capture and share social spaces in real time, and rather than having a fixed view from the remote person, support independent views. So we use the Google Glass to capture your surroundings, and oh, how funny, it's my phone. Please turn it off, that's great, thanks. So you can use a Google Glass to capture your surroundings and then share that as a static 360 picture to a remote person who can view it on their tablet. And the tablet, of course, has a compass in it, so they can view it and turn the tablet around, look to any perspective from that picture, and then they can also annotate it on it as well. One of the important things about this, though, is now the remote person isn't looking where you're looking, so you might need to know where they are looking. So we built a little interface here, and you can see the top right-hand corner, there's a blue and a red bar, and those two bars show where both people are looking, and so when they line up, they're both looking in the same direction, and when they're moving apart from each other, they're looking in different directions. And with a tablet, you can also annotate on the screen as well. So here's the video of this working. So my student, Caroline, is going to this very nice park. She captures that as a 360 image, shares it with her friend Adrian, who's still at work, and then they're going to talk about the park together. And one of the things you'll see is that they can draw on the image they're sharing, and so then they can communicate very naturally by using pointing and drawing gestures. So she shares the image with him. He's got a tablet which has a compass sensor in it, so it can look around. And you can see the blue bar and the red bar are lining up, so now they're looking in the same direction. He's using his finger to move a mouse pointer on the screen, and now he's drawing a little bridge over the river and saying what it would be like if there was a bridge there. So this is really great because now it lets the remote person have an independent view from you. They can look around wherever they like. But the problem, though, is that, of course, this is on a still image, and you know, it's not so very realistic. So a couple of years ago, a flood of inexpensive 360 cameras came onto the market, and many of these let you live stream 360 video, and they just cost a few $100s. Like the Theta S there, for example, is about $350 US. So we took one of these cameras and extended what we did before into a 360 live stream experience. So this is the shared sphere from last year. So you have a person wearing a Epson AR display with a 360 camera on it. They can live stream the video to a remote person who's got a VR headset on, and he also has a Leap Motion tracker on his headset, so he can put his hands in front of his face and they get tracked. Then the person in the VR headset sees the 360 video, so they really feel like they're immersed inside the video. The person in the AR headset can see virtual hands coming back to him, so he feels like there's hands floating in space in front of him, and those hands will point out how to do a task. Again, we still have to have the awareness of where people are looking, so we have these red and green rectangles appearing, showing where each person is looking. So here's some of the functionality. We have an AR-VR collaboration. We have view independence, so one person can look separate from the other person. We have view awareness cues, and also these very natural gesture cues. So the view independence means that when the person streaming the 360 videos turns their head, the person at the other end doesn't want the video to move, otherwise they'll get to feel sick. So we use some image stabilization software to stabilize the video and fix it. And then here's the showing again how the image doesn't move at all. These are the view awareness cues. So we have these red and green rectangles showing where the person's looking. And then most importantly, when you look away from where your friend's looking, we put an arrow on the screen showing you where your friend is looking. So if you want to align your views, you can easily look back if you want to. And We also share these natural gesture cues. Of course, coming from the sender's side, we can see the real video of the real gestures, so we don't have to share that. But coming back, we have the leap motion that will allow us to send the virtual hand of the remote person back into your space. And using that, we can make a wide variety of gestures like thumbs up and fist gestures and pointing gestures and so forth. So here's a video of this working. So you'll see, again, there's a setup. The guy wearing the hard hat is now streaming this video. So now I'm feeling like I'm standing in the office with him. I'm looking around separate from him. This red square is where he's looking. So when I look away from him, you'll see and there's the hand gestures that I'm making to point at objects in the real world. And so this is what he's seeing. He's seeing an AR view and then the virtual hand floating in front of him, space in front of him. The BT200 has a little bit small field of view, but you still get to see each other. We use the orientation sensor to image stabilize. So without the sensor, the image jumps around. With the sensor, it kind of self-stabilizes. And then they can, then there's the arrow there showing where the person's looking, and they can start performing tasks together. So that was a year ago. And since that time, we've extended that further. We've most recently, just a few months ago, released a new version that now supports remote pointing. So I can have my hand, I can make a point gesture, and a virtual laser beam shoots out of my hand and highlights objects in the real world. We can also do drawing. We can now stream audio. We have a backpack VR set up so that the remote person can walk around. We use a HoloLens display now rather than the Epson BT200, and we have a HTC Vive. And we also have a much better 360 camera. And we're testing this with industry now in South Australia with the power industry. So here's a video of this working. So you'll see in this video, the guy looks at this switching board, and he's got the HoloLens on his head, the hard hat and the improved data capture system. And then he's able to see this virtual hand, but now the hand can point at objects in the real world and also circle them and make annotations on those objects in the real world. A little bit like what Microsoft showed, except in our case we can see the full 360 video, not just a small portion that the person's looking at. And so here's the person on the remote side. He's got the Vive on his head and the leap motion again still, and is able to make a series of hand gestures to communicate back with the other person. So this is what he's seeing in his head mount display. So it's very, very natural collaboration. Although one limitation that's obvious, of course, in this case is that both this and the older application, you're seeing a 360 video or a 360 image. So it's a flat kind of image of real objects. So there are a number of technology trends that you'll see at the conference today or tomorrow, and you're probably all aware of. So first of all, a lot more advanced displays happening. So we've got much wider field of view displays, high resolution displays. We're now getting real-time scene capture. So within a few years, you have to walk into a room, and instead of sending a 360 video of that room, you have to click a button and capture a 3D model of the room and stream the 3D model. There's much better gesture recognition software. There's people working on eye tracking and also motion sensing as well. So we're looking at now how we can combine some of these together and to provide an enhanced remote collaboration experience. So for example, a couple of years ago, we combined eye tracking with a see-through display and a special pair of glasses that measure your face expression into what we call the empathy glasses. And what this meant now is that I could do the remote collaboration, but now I can see the where the person's looking. So previously with the Google Glass or with other systems, when you stream the video to a remote person, sometimes the camera had a quite wide field of view, like 60 or 80 degree field of view, and the remote person doesn't know exactly what you're looking at in that view. So by using this setup, we know exactly what that person's looking at, and it really changes the nature of collaboration from an explicit kind of collaboration to more implicit. People always look at things before they pick them up, and so by watching somebody's eye motion, we know what they're about to do. So here's the system working. So he's got all this stuff on his head. He's now arranging, the person on the right's arranging these blocks and sending video to the remote helper, watching on his monitor. And there's the helper there. You can see there's a green spot, and this is the helper's mouse position. But most importantly is the red spot, which is the eye position of the person doing the block sharing. So when the helper asks the person to do something by moving the mouse and saying, move this block over, he can tell whether the person's paying attention or not, because the eye spot should follow the green spot. And so it changes the nature of conferencing quite a lot. And there's also a heart rate sensor and a face expression sensor. So you might have seen in the video that the face expression would change a little bit as well. What we're also looking at is how we can capture scenes. So last year we built a system that has depth sensing on the head mount. So here's a person in their office, and they can slowly pan their office around, and we can create a 3D point cloud of what's in front of them in space. So it's not instant capture, but it just takes a few seconds, and you can create a 3D model of your office alcove there. And then we can share that 3D model with the remote person now as well. So instead of having the live video, we've got a full 3D model. And so in this next video, you'll see how we're able to do that in a collaboration scenario. So here's a local worker looking at these real objects, and he's scanned them and made a 3D model of them, and now the remote expert is able to look at a full 3D model of those objects and is using a 3D pointer to interact with those objects as well. So it's much more realistic that the remote expert can now walk around the scene independently. And you'll also see these white lines. These are now view frustrums. So instead of having a red or a green rectangle showing where people are looking, we've got a whole view pyramid showing which direction they're looking in and where they're going as well. So this is much, much more natural, although still a lot of room for improvement. So these kind of 5 trends together, all combined, are trending towards something we might call augmented teleportation, where we can really feel like we're in the remote body of somebody else, and we can see what they're seeing, we can interact with what they're interacting in 3D, and by sharing the eye gaze, and we're now working on emotion sensing as well and stress sensing, we really get a sense of what they're feeling also. So just to wrap up, what I've talked about today is augmented teleportation, showing how you can use augmented reality to remove the communication seams that you often have with today's technology. You know, the seams we have when we try and use Skype with remote collaborators, or we huddle around a monitor in the real world and we can't see what people else in the room are doing. Augmented reality also allows us to have view independence and share rich awareness cues, and also use very natural communication cues such as drawing and pointing and gesturing. In the future, there's a lot more work that could be done, and that's what we're doing in our lab, looking at how we can have much richer non-verbal communication cues like eye gaze or face expression. We're also very interested in scaling up to one-to-many sharing. There's no reason why the person who's sending that copy of the real world needs to only send it to one person. They could send it to dozens of people, and all those people could be inside that person's body virtually and helping them perform a task, just like you saw with the Microsoft where they had 2 people on the call. And there's a lot of great research happening right now on better scene capture. So, you know, in the next 3 to 5 years, there will be technology that will allow you to, just in a few seconds, to capture a 3D model of your real environment. And in fact, live stream that model. So if people are dancing or moving around, you can capture those people as they're moving and stream them as well. So that gives you one glimpse into what we're doing in our lab. As I said at the beginning, if you'd like these slides, just send me an email. I'll send you all the slides in the video. And if you'd like to find out what more we're doing, please visit our website or follow me on Twitter. So thank you very much. I think we might have time for 1 or 2 questions. Or, yep.
You mentioned trying to get the task space within as a subset of the communication space. If you try to scale up one-to-many, wouldn't it be potentially a nice idea to have the person not centered on the person, but visually around them so that you could see where people are looking via avatars and things like that?
So, yeah, so actually if I had 10 more minutes, so other work we're doing is being able to so in the videos I showed you, you were virtually inside the person's body, but there's no reason why you have to do that. So once you've got a virtual copy of their real world, you could move your virtual avatar anywhere you want. So we're doing some other work where you can scale yourself very big or very small, or move separately from the person. So we can do just like what you said, we can move out of the body and still look at what the person's doing in the real world, but look from a different perspective, from exocentric rather than egocentric perspective. And I've got some very nice work we've done where we scale our avatar. So we might have a scenario where you've got a small group of people doing something in the real world, like an emergency response situation, and you might want to have 1 or 2 people that can monitor what everybody's doing. So they scale themselves up very big to kind of giant size, and they can look down into the copy of the real world and see all the people in the real world moving around doing their task. So that's definitely a great approach for collaboration, yeah. And we're working on that, definitely.
So Microsoft just released a new version of the Kinect. I don't know whether it's fair to call it a Kinect anymore, because it's just a cloud array-based node of a 3D scanner. or something like that, and then you can use lots of them in a room, and they'll all talk to each other and ostensibly construct a volume with all that dense multi-point data. That really opens the door for a lot of what you're talking about in these scenarios, but it's predicated on having a model of the room or having a scanning accommodation in the room. In terms of wearable technology that's specifically designed for immediate area acquisition, the off-the-shelf tech that you've used and 3D sensors and depth sensors, do you feel like those are adequate for them? I mean, you said the update rate takes a couple of seconds. It's still kind of slow. What would, if you had your druthers of something you could add to a visor that would really solve a lot of problems?
So the Microsoft Connect looks really, the new version looks really exciting, and we'll definitely be using that. Intel have their own RealSense, and then Occipital, who are talking at the conference here, have their structure sensor as well. So a number of different technologies that I think you can work off the shelf with. One of the challenges is that some have limited depth sensing range, so some work very good at short distance, some long distance as well. But I can easily imagine a scenario where the user themselves actually doesn't necessarily carry the technology. I could easily imagine in 5 years in the future, you've got a small drone that you walk into a room, you throw the drone into the air, the drone flies around and makes the 3D capture. Because if I'm capturing from my position, I can't capture from behind furniture or under things. So if I've got a little drone I can throw into a room, flies around for a minute or two and captures everything, and then I'm continually updating the model from what I can see, then that's probably a better way to do it. The other point which is really interesting is that once you've got a large amount of this data, it's very inefficient to send gigabytes and gigabytes of pixels remotely. So you really want to do some semantic analysis, and you can use deep learning to automatically segment out different objects in the room. So if you know where the walls are, I don't need to send hundreds of millions of polygons describing the wall, because the walls are mostly flat. So I can just replace that with flat objects, and then I can automatically segment out objects in the room. And okay, here's the furniture, here's the people, here's the pot plants, and now that adds a whole another meta layer on top of that environment as well. So I think you'll see a lot of very exciting things happening in the scene capture space in the next year or two. Great, thanks a lot. Thank you for your time.